Perfect. So now I really have to be careful about what I say, yeah? All right. Okay. So why do we have an API? Why are people using the API, first of all? So APIs are essentially a way to interact with some service online programmatically. So in our case, the service is the Dimensions database, and so people want to access the data not manually by typing things in using an interface, but by essentially having some automation essentially doing these operations for them. So some code running that essentially pulls out the data for you according to your preference. And in general, I think it's always useful to summarize, what are the main reasons why people come to the API, the Dimensions API. So the first one, you may have, some people have queries that are very complex, yeah? Queries where there are a lot of filters, or maybe the search strings, they contain a lot of variations, maybe in different languages, different spellings, and so on. And so building out these queries using the web app can become a bit cumbersome. So you all right. So people would use the API in this situation because you can essentially write up the query using some programming language and it's much quicker. And this becomes even more important when you think of queries like citations analysis or building a collaboration network for organizations. So these are queries where essentially you start from an object and then you get all the related objects, and then you want to repeat that operation over and over because you're trying to build a network of related objects. So doing that via the UI or manually is really cumbersome, and that's why you would use the API for that. Second thing is people want to automate query composition. So in this case, the queries, they may not be very complex, but you want to run the same query over and over, maybe at different points in time. So maybe you're doing an analysis about coronavirus and you want to get essentially an overview of how much new content appears over the weeks or over different months. And so that kind of automation allows people to build reports or to build dashboards that then can be essentially used by end users or analysts or decision makers to get insights into some domain area. And finally, people come to the API because they want to get more data than what the web export functionality allows. So with the web export functionality, you can get up to 50,000 results. With the API, that's also a limit you have in general for any query you have with the API. But with the API, it's so much easier to slice the data in different ways. So for example, you can take a query and segment it by year. And of course, you do that programmatically. So it's not really extra work. You just have to schedule your queries in an appropriate way, and you can easily come back with hundreds of thousands of results. And actually, some people, they get millions of data from us, and which is not necessarily something that we want to encourage in some cases, because the API is primarily, well, it's called an analytics API, the main API we have, and that's because we want people to essentially come up with clever queries that help them get some insights pretty quickly in the problems they're trying to solve, rather than downloading a lot of data. Now, having said that, we are also working with customers that have some genuine use cases where they do need a lot of data. So the API supports also that kind of um, application. Right, now very quickly, I'm not going to be spending too much time here, but we got three main API products. The Analytics API is the product I'll be using today. And that's also the most advanced product we have. We make releases very frequently. That's every 2 weeks in general. And the main customer type here is our analysts or data scientists, so people who have complex queries and they are willing to learn the language, the API language, in order to get answers to these queries. The API is throttled at 30 queries per minute because we essentially want to guarantee the same level of performance to all of our customers. But other than that, you can do whatever you like with the APIs. The other two products we have, the Runtime API and Chris API, are kind of small variations on the Analytics APIs. The Runtime API is not throttled, meaning that you can run as many queries as you want. But it's much less limited in terms of the operations you can do. So basically with the runtime API, you can simply pull data about publications, grants, or the other content types. And that's used primarily with by customers who have to integrate this data quickly with some other software. And finally, the Queries API, it has pretty much all the features of the Analytics API, but it's updated only once or twice a year. So it's less, well, it doesn't have all the cutting edge features, but on the other hand, it's much more stable and reliable. And this is used primarily by Queries systems, where whereby there's no need for advanced analytics features, but essentially you want to make sure the system is always up and running and pulling data at a regular speed. Was there a question? Someone saying something? No. Okay. Right. So, well, all of these different API products have in common is the dimension search language. This is essentially our own API language that was developed over the years. And it's a language that essentially has been developed with analysts in mind. So there's another very popular approach with APIs, which is called REST. And I would say it's much more developers oriented. So with the DSL, the idea is to essentially empower people who may be closer to the subject domain, people who may understand the scholarly analytics area from the point of view of what are the key questions, the interesting things people want to ask, and letting them essentially do something useful with the API, even though they're not programmers or even though they don't have enough time to set up a programming environment. So the DSL, the dimension search language, is structured around two phrases: a search and a return phrase. As you can say, it's based around the English language, and the object of the search and return statements is one of the main content types we have in dimensions. So in this case, I'm searching for publications and returning publications. And of course, I can put in a number of constraints, parameters, filters, in order to identify things I am interested in. So there could be full text constraints. So for example, the leukemia keyword, there could be filters on ears or on many of the parameters the API allows. Now, it's important to remember that you don't necessarily have to return the same object you're searching for. This operation is called faceting. So people with a background in library science are probably familiar with the term, but essentially it's a little bit like grouping results based on another dimension. So in this case, I'm searching for publications, but I'm pulling out researchers. So what that means, I'm essentially extracting all the researchers related to those publications. And I could do the same with journals or even years, yeah? And then essentially, it's an operation which is very similar to the facets you see in the web app on the left-hand side, where you see only the relevant objects for that specific kind, relevant to the search you have currently done. And that in itself is a powerful thing to have in the API because it gives you some analytics right there, meaning that, if you have, for example, with the coronavirus, people have come up with a nice full text search string. Essentially, instead of leukemia, we have a number of coronavirus names and synonyms and other things that essentially make the search more relevant. And then by returning, for example, researchers or ears or journals, we would know right away who are the top researchers working in this area, or which ears have the most content on this topic and so on. So that's already a very quick operation for getting some insights into the content available in dimensions. Very quickly, the DSL doesn't have just search statements, but there's also a number of very interesting special functions. We call them special fundamentally because they have nothing to do with searching documents, but they perform some other kind of operation. So for example, we can extract affiliations. This functionality specifically relies on grids. And so from an affiliation string, you would return a grid identifier. This is used very much, for example, in context where a client has a number of internal documents that are not public, and they want to classify them in some form, and in this case by adding grid identifiers to them, so that they can use them in analysis that are essentially combining data coming from dimensions as well, right? So in a very similar fashion, we can extract concepts from text, and we can also classify text using one of the many classification systems available in dimensions. Right. So how do you access the API? There's different ways. The easiest one is via the Dimensions app. If you go to app.dimensions.ai/DSL, I believe there's also a hyperlink on the top right menu. To get to this page, you will see a search box that allows you to write an API query and to get back some results in JSON format, which is the default format we use with the API. So this is a very handy way to try things out with the API. But of course, it's also a bit of a dead end. Yeah, we don't really expect people to do much with this, because as I mentioned in the beginning, the power of the API is in the automation of this kind of queries. You want to run many of them and different times, and then do something with the data coming back. So that's why a lot of people, they use third-party softwares in order to do things with the API. So things like Postman or Click, Tableau, so business intelligence tools or data visualization tools that know how to talk to APIs. So you would essentially put in a query there, and then that software would essentially know how to process the data in order to build a visualization, for example. I'm thinking here about Tableau. Tableau knows how to parse JSON data and, for example, build a time series or a bar chart out of it. So that's a second way of interacting with API. But by far the most, not efficient, but probably the most prolific or creative way of doing things with API is by using a programming language. And that's what most people do. So the API can be accessed, it's kind of programming language agnostic. It can be accessed using any programming language. And we have people using Python, R, Java, and others as well. But of course, internally, we have been using Python a lot. And that's also a very, very popular programming language at the moment. And so we also developed a library, Dimcli, that essentially abstracts. It creates some simpler ways for doing repetitive operations, such as logging in, logging out, paginating queries, and so on. And that will be the main thing we'll be looking at in a few moments. Right. I should say the API has extensive documentation. You can find it online if you didn't know about it. And you will find lots and lots of information about all the fields we have, all the content types, the rules of the language, and so on. So let me now move on to today's topic, unless someone has, let me see, can I actually see what people are saying? I don't think there's any questions, but all right. Okay, so Dimcli. It's an API Python client. As I mentioned, it's an open source project. You can find it on GitHub. So if you're curious, you can actually take a look at how it works internally and modify it and make your own version of it. And it simplifies common API operations such as logging in, logging out, storing your credentials on your computer, building queries, building iterative queries, essentially queries where you get more than a certain number of results. And so you have to paginate through different API queries. And it also has a number of functionalities for turning the data you get from the API into data frames. So data frames is kind of a tabular format for Python. So you can think of it a bit as Excel spreadsheets for Python. It's super popular with data scientists, but not only. And data frames are really, really handy because essentially, like with the spreadsheets, you can easily start sorting tables in different ways. You can build pivot tables, you can group them, and so on. Right, and then Dimcli includes also a command line interface. Now, getting started installing the command line interface is probably a little bit harder for people who do not do any development normally. But once you have it, it really, I would say, it really pays off the time you spent on it. Because a command line interface essentially is kind of a query console. You can see it on the right hand side there. It's an environment where you simply launch one query at a time. It's not really meant to be used for programming or building applications. But the nice thing about it is that there is autocomplete. So the dimensional search language is very, very rich. You know, we got 7 different content types, and each one of them has, you know, 20, 30, in some cases 40 different fields. So remembering all of them, how you can combine them together and so on, you know, takes a lot of time. So by having something like this autocomplete that includes also descriptions and suggestions, you can really, you know, start, you know, trying things out and, you know, develop queries in a very interactive manner. All right, so I think next step here, I will show you a little bit about where Dimcli is. Well, I say Dimcli, also Dimcli, I think, depending on, we don't have an official pronunciation for this name. But anyhow, let me think how to best handle this. So as I said, it's an open source library. If you're a developer, you can find it on GitHub. If you're not a developer, most likely what you want to do is installing it, right? Now, I think there's two options here. If you're familiar with the command line, meaning you've done things on it already, essentially all you have to do is to have the Python package manager called pip, and then Dimcli is kind of a public package. It's a public library that can be installed easily simply by writing down pip install Dimcli, and that will install the library on your computer. And that, of course, is if you know how to do these things. If you have already used a terminal in the past, for example, or if you know how to open up a terminal within an environment like a Jupyter Lab or Anaconda. Now, of course, this is not something I can cover today, but for people who want to know more about that, please feel free to get in touch. There's also plenty of documentation online on Dimcli, because once you have installed it, you can essentially initialize it. What that means is that you can store your API credentials on your computer once and for all. You simply type in this command, and there will be an interactive prompt that will ask you your username and password. And then once that is stored, you don't have to worry about it anymore. And you can simply say Dimcli login, and it will start. Right, so I've got here open Jupyter Lab. I will show you simply what it looks like. So from a Jupyter environment, you have access to a terminal also from here. So if you have something like Anaconda installed on your computer, you can open up a terminal there and try and make this bigger. Oh. Okay. Oh, lovely. My computer is crashing. Can you still hear me?
Yes.
Yeah, all right, okay. So I think Jupyter is crashing. Let's see if I can, maybe it's the browser. Okay. Let me see if this works. Ah, there we go. Oh, maybe it was I zoomed in too much. Okay, here we go. So essentially to install it, the command I was showing you before is this one, pip install Dimcli. Enter, and of course here it's telling me you have installed it already. If you haven't installed it, it will just essentially pull the library and it will install it on your computer. So once it's installed, if you type Dimcli, what you can see here is this essentially query console, the one I was talking about a few moments ago. And so if you go through the hassle of installing Dimcli, especially if you're a non-tech person, as I was saying, the advantage is that now you have an environment where you can search via autocomplete. So for example, here I'm searching publications where say all metric, or maybe, for example, I don't remember what is the citations count field. I can simply go through all of these fields, and there is a short description at the bottom that tells me what the field is about. So I'm looking for publications cited more than 100 times. And let's pick a category as well. Well, we got the SDGs now, so I can do where SDG.name equal, and I have actually baked into Dimcli a list of all the categories. So this is also a handy way to remember what categories we have. I always forget about that. So let's take life below water. And now I say return. And as you can say, I can return a lot of things, yeah? And this is one of the nice things about the dimensional search language. I'm gonna return publication just as a start. That's the main thing. Of course, you can return from this query. I'm searching publications and I return publications. So Dimcli kind of, tries to prettify things. And, the whole point of this environment is just exploring essentially the data using the API. It's not really allowing people to build applications on top of it, but just getting a feeling for what's available. So Dimcli shows me the top 5 results in a kind of a pretty format. I have the URLs for the dimensions objects if I want to open them up on the browser. It tells me how many results I have in total. But now the thing I will show you is the faceting operation we were talking about a moment ago. So all of these other field names you see here, these essentially allow you to facet on a specific dimension related to publications. So if I facet by journal, for example, I'm pulling out here the top journals linked to this search. So marine pollution bulletin, science, and blah, blah, blah. So the top 5 I show there. I can say show 20, and I get all of them. If I modify my query and I say pull 500 journals, there's 400 in total. Now I got 500 journals there. And Dimcli includes also some handy features for extracting the data from this environment. So for example, I can do export as CSV. It will essentially build a CSV file I can open up in Excel, or export as HTML if you want to show that this data to somebody, and you get the JSON results into a nice HTML page. And that's it. There's history as well, so I can go back to my previous queries. Right, and I think that's all I wanted to say about Dimcli, this command line tool. So it might be a bit of a hassle to install it if you're not a tech person, but please ask people for help, because I think it really pays back in terms of learning about the API. Now, the second way to use Dimcli without having to install anything at all is simply to use Colab, right? So I'm going to go now to the API lab, .dimensions.ai, which is essentially our open source collection of Jupyter notebooks. They use the API to perform some, some specific scholarly analytics operation, let's say. There's a bunch of getting started notebooks as well to show you what you can do with Dimcli. And then we have a selection of notebooks based on different topics. I should also say that we have a massive backlog of notebooks that we're putting in this environment. We're simply pacing that because we're making sure that every time a new notebook gets published, it's fully supported. It works in different, it works for everybody. It has enough documentation and so on. Anyways, we have basically new notebooks being published here every month, every couple of weeks or so. Right, so I'm going to open up now from this web page this, let me see, this notebook called Installing the Dimcli Python Library. This is, of course, an HTML page. It's a read-only. I cannot do anything here. But if I click on the Opening Colab page, it will essentially take the Python notebook behind this page and open it up using Google Colab, which is a cloud-based Jupyter environment Google makes available for free. Yeah, basically. It works a little bit like a Google Doc. You know, you can share this with people. You can comment on cells. There's a version control embedded in it. So there's a number of very interesting features. But I think maybe the most interesting feature is that you do not have to install anything on your computer. Yeah, you can use the API from a notebook like this right away. Yeah, and I know a lot of people really like this because you know they don't have either time or enough technical expertise to get up and running. So once you're here, so here I'm fully within this notebook environment, which is a copy of the notebook in the API lab. I can essentially play these cells. I can run them. You know, this little play sign essentially means run this command. So that pip install Dimcli is the same command that was running locally on my computer before. Now I install it here. I run it here. The exclamation mark at the beginning is kind of a special syntax for this command line commands when you run them from within a notebook. You don't really have to remember about that. Just remember it's question mark pip install Dimcli minus u means update if there's already a version. So the very first time this thing will tell me, you know, Warren, this is not a notebook that, you know, this is not owned by Google. Make sure you know what you're doing. So we just obviously say we totally know what we're doing. And so what's happening here is that, you know, the Dimcli library is being downloaded and installed on this Colab environment, right? And now we have it. Now if we do import Dimcli, everything works, yeah? So the next thing we want to do is logging, yeah? So here I've got some test login credentials I'm going to put in here. And then my password for today. App, the endpoint, app.dimensions.ai is the default endpoint being used. But of course, if you're using another dimensions version, you would have to put in the one you're using. So for example, as an insights or others. So now I'll hit play here and hopefully, yeah. So it says, yeah, Dimcli has connected to the API and essentially I can start querying the API right away. So now we can skip all of this section about storing private credentials. You can read through that. But I will show you how you can query essentially. So normally what you do is instantiate this object called DSL. You just say, I want to create a new object based on this template called DSL, and then you do DSL.query. That's the normal syntax for launching queries. So that's my query, search for publications for black holes, return publications, and here I say store the result of this query into the data variable, right? Now, the data variable, essentially, the results of a Dimcli query, have a number of useful methods one can use. So let me see. I'm going to add a few cells here. So if now I do data dot and tab, as you can see, there's a number of things that the results of Dimcli make available. I can do count batch. It tells me how many objects I received back. Count total. That's the total number of results of this query. I can do data.json, and that's actually the raw JSON data the API is sending back. As you can see, there's 20 publications in here, so there was quite a little bit of JSON. There's some kind of shortcuts. I can do data.publications, and it returns me the JSON for publications. In this case, that's the same as data.json. But if you remember before, I can say return publications and return another thing. So JSON will give me everything, but if I do data.publications or data.whatever you returned, it will give me only that object. Now, let me, right. So that's how you launch a query, essentially. So you do DSL.query and you put in a query. Now, as you can say, well, as you know, as you may know already, every query in with the API can return a maximum of 1,000 records. So if I say search publications, return publications, yeah, the most stupid query you can think about, and say limit 2,000. If I say, oh, give me 2,000 records with this query, you get an error. It says, oh, 2,000 exceeds the maximum allowed limit of 1,000. So there's 1,000 maximum records per query. And in this case, it works. But what you can do is essentially, you can use the skip operator to paginate through different pages of this query. So if I say skip 50, I get the 1,000 results starting from the 50th one. So I can essentially say skip 1,000, and this will give me results from 1,000 to 2,000. And this operation is called pagination. It's like going through different pages of a result set, and you can do it up to 50,000 results, right? Now, if you have a query that returns more than more than 1,000 results, you want to get all the data, you can manually essentially write all of these queries, limit, skip, or maybe write your own function to do it. But of course, that will take some time. It's not really the best way to do it. So Dimcli includes this functionality, which is called query iterative, where can I ask folks to mute yourself, please? Thank you. All right. So query iterative, essentially, it does all of that limit and skipping thing itself in the background. So in this case, my query, which is search publications for black holes from 1990, which are cited more than 10 times. So there's 3,362 results. So it will take 3 or 4 queries to pull that data out. But by using query iterative, essentially, I can pull all of them out in one single command. And just remember, this will work up to 50,000 rows. Yeah. So I can have one command that pulls out all the data in one go. Now, a few other things about Dimcli when used within a notebook, which are useful to remember. Let me add a few code blocks. It includes a number of magic commands. Magic commands are a little bit like shortcuts that can be used within Jupyter. Yeah. So magic commands, I don't know what they're called magic commands, but anyhow, it's funny now. But they all start with a %sign, and there are as I mentioned, it's a shortcut for something longer. So %DSL is a shortcut for DSL.query something. So if you don't want to, if you just want to, try things out, that's a nice way to do it. There's also a basic autocomplete functionality. It's not as good as the other Dimcli you've seen, the command line one, but it still works to some degree. Yeah. So if I say search publications where category for, I don't even know whether it works with names. Oh yeah, it does. Yeah, as you can see, there was a little bit of repetition there. So now I'm pulling statistics, publications, and year from 2010 and onwards. And now I say return publications. So in this case, just from one single line, I can get the results back. You don't see any results here. When you use those magic commands, the results are stored in this kind of magic variable called DSL last results. So if I say now DSL last results.json, you get the results back. I could even have a loop query. Yeah. So if I say DSL, I don't even remember, what is it? Is it DSL loop? Yeah. So this is now essentially running one query every 2 to 3 seconds and pulling out, well, there's 328,000 records, which is way too many. So it will stop at 50,000, but it will keep going until it gets there. And then the results will be available in DSL last results. So I'm going to stop this. All right. Now, how are we doing with time? We still have 5 minutes, right? So I'm going to show you just another thing, and then we'll probably have some time for questions. Hopefully people will have a bit of extra time because we're running over. I mentioned about data frames. That's another really handy feature. I will show you just a quick example of how these data frames work. So I'm going to take the query up here, right? And instead of using DSL loop, I use a command called DSL df. df stands for data frames. Yeah. Let's pull out 500 records. So in this case, the data coming back is transformed directly into a table for me. So the JSON results, which are probably really handy if you want to do some further development on that data, you don't see that no more, but you see a table. This data frame can also be really handy for other kind of operations, but it's also just very useful to see the data. Yeah, you know, we use it all the time just to have a look at what's coming back. And in particular, if you use this within Google Colab, the tables printed out, they have a filter built in that you can use to look into the data. And I think they already have a built-in pagination here. You can scroll through all the different pages of these results. You can decide how many records to show per page and so on. So essentially, these data frame transformations Dimcli has are another handy way to try things out and to move from one format to another. And so that DSL DF shortcut, in essence, is exactly the same as this query. So here I say DSL.query, and this gets me back the JSON results. Then I do as data frame. There you go. Now, as data frame essentially gives you a table containing all the data in your query. As you can see, authors, as well as other things, are they contain nested objects. That's obviously because every paper has multiple authors and every author has multiple affiliations. So data has to be structured if you want to have all of it. So these data frame methods, essentially, they have some, they have a way to unpack these nested objects so that you can see all the authors right away. So sorry, now I'm messing things up a bit. So I'm going to do save the data first. Okay. Now I do data dot. So as you can see, I have as data frame authors, I've got as data frame author affiliations and other things. So as data frame authors, if we look at that, for example, this is unpacking the author's nested object. And instead of getting one row per publication, I get one row per author. So of course, the same publication ID appears on multiple lines. And this is really useful, for example, if you want to count authors, if you want to know how many authors come from France, yeah, or stuff like that, right? Another way to deal with this is to use this as data frame author affiliations. In this case, instead of having one row per author, I get one row per affiliation. So, and very often affiliations have a grid identifier. So this is essentially what you would use if you want to do some further processing based on the affiliation. So taking the affiliations as a starting point. And I think I really have to stop here now. Sorry if I had to speed things up, but I realized today that, you know, Dimcli has so many different aspects that maybe it was too big a topic for a session. Anyhow, have we got any questions or anything you guys would like to add, or yeah? I thought someone was going to say something.
Michele, this is Jennifer. Just a question for you about logistics for our subsequent sessions. Maybe this is even a question for Christian. Will we know what the topics of focus are in advance?
Yes, that wasn't, this one was basically a little bit improvised because we didn't know, actually we were not expecting for such a high turnout too, so thanks for that. We will always send on a Monday morning the email with the topics of the week. so that you can decide whether it's for you or not. Spoiler alert, one will be definitely about the just lately released Google Sheets integration with the API. So that you then can decide whether it's interesting for you or not. I think this one was meant to be a Dimcli integration. The next time we will always try to stick to 10 minutes, a very quick general introduction, and then focusing on one use case. More specifically, I think Simon is preparing using, unfortunately, a recent example with COVID for the next week. So, and I hope that Monday is enough, but that allows us also to be a little bit flexible with the feedback.
Perfect, thank you.
So we also will send around after this one for the participants, if there are not any questions, the recording, because I think especially with this topic, it might be worth sometimes to scroll back, or at least I will do it when I try again my luck with Dimcli to the points where I get then the inspiration what to do next. Any questions? Mindful of time, we are running over. I don't know whether you have more time. I think also Michele is available via Slack and email. We just need to take into account that he is in the same situation, so he might not be able to respond to everything. If there are questions, we might also gather them and answer them in a more collective way so that the load is not on him. Other than that, looking forward to see you. I was happy to see so many of you here today. And yeah, let's meet again on Tuesday and Thursday next week.
Awesome. Thanks very much for the attention.
Thank you.
Thank you. Bye.
Recording will be provided. That was just a question which came in. Yes.
All right.
Thank you. Bye.
Bye-bye.
You.
Thank you. Bye.